get alpha, we would then have to shift tan of 5 over 3. So if we do that, shift tan 5 over 3, it's going to be 59, comma, 04. Okay, so let's round that off nicely. So 59, comma, 04. So remember, all I did was I shifted tan of that gradient. Okay. 1.4 says, if theta equals 76, determine the line through A parallel to BC. Okay, so what they're saying is, if this angle over here is 76, okay, they want, if I were to take a ruler here, if I take a ruler and I make a line that goes through A, so it looks something like this. I make a line that's parallel, so this line is parallel to that line. They want the equation of this line over here. Okay, and I know that's a little bit confusing, but if you think about it, right, we have a point. We know a point that it goes through, and the only other thing you ever need to find the equation of a line is the gradient. And they're telling us that these two are parallel. So if I can get the gradient of this line, it will be equal to the gradient of that line. Does that make sense? Okay, so how do we get, I mean, if they've given us this angle over here. So gradient and angles, what do they have to do with each other? This tan theta formula. Okay, so, I mean, we don't have point C, so we can't just use y minus y over x minus x. But we do know something about these angles. Now remember, we worked out this angle. It's 59,04. And you can clearly see that this is a triangle. So do you agree with me? I can get this angle over here by using 180 minus 76 minus 59,04, which gives me 44,96. All right. But remember, when you are using your tan theta formula, because I want to be able to say tan theta equals m, and then I want that angle. Oh, I mean, I want the gradient. Sorry, we're looking for the gradient here. I want that gradient. This angle has to be what? It is the angle of inclination. So if you're considering this line and you want the gradient of this line, okay, it's not this angle, it's the whole angle from the x all the way until there, like I explained over here. Okay, it's this full angle from your x. You always go clockwise from your, anti-clockwise from your x. Okay, so I'm going to need that angle in order to get this gradient. So this angle is also, it's a straight line, so I can just say 180 minus 44,96, which is 135,04. Okay, you could also have used exterior angles of a triangle. In other words, this one equals these two added together. All right, but now we know the angle. So we can go and say tan of 135,04, or you can say m equals that. Therefore, the gradient is equal to, and you work it out for me, tan 135,04, which is minus 0,99. I'm just going to round this off to minus 1. Okay, because it's a whole bunch of 9s. So I'm going to round it off to minus 1. Now remember, this is just the gradient. They are asking for the equation of this line that's parallel to that line. Now that is when you can go and you can use this formula over here. This y minus y1 equals m times x minus x1. Are you with me? Okay, so in using this, you're going to use this point because this point A is what goes through that line. And then remember, you leave the second y blank and the second x blank. This one here that doesn't have a number. Okay, so it's going to be y minus y1 is minus 3. So y minus minus 3 becomes y plus 3 equals m. We know the gradient is negative 1, open bracket. X is going to be minus 5, we're leaving x blank. And then minus 5 becomes plus 5. Okay, you could also use the method if you want to, where you jump straight and you say y equals mx plus c. You then fill in your point, so your 1 point is -3, your m is -1, your other x is -5 plus c. Then you go and work out c and you fill in everything if you are used to using that method. Otherwise, you're welcome to use this formula. So now we can go work it out. So y plus 3 is equal to minus 1 times x is minus x, minus 1 times 5 is minus 5. And then all I have to do is take the 3 over. So it becomes y equals -x. And then minus the 3 will be -8. All right. So let me just run through what I did in this example because it was quite difficult, this last question. They asked you for the equation of a line that's parallel to that line. But they didn't give you the gradient. They didn't give you point C. All they gave you was this angle. So I then used these angles to find this angle of inclination, because I have this tan theta equals m. So now I can use that tan theta equals m to get the gradient of this line. Remember, they are parallel, so once I get the gradient of this line, I immediately have the gradient of that line. So I can say the gradient is equal. Since I had the gradient of this line and a point, I could go use that formula, y minus y1 equals m times x minus x1. Then you fill in your point and your gradient, and you just multiply it out. Okay, I hope that makes sense, grade 11, sorry. Let's go on to example 2. Okay, example 2. It says A, B, C, and D are the vertices of quadrilateral ABCD such that the diagonal AC is perpendicular to BD. So they are saying this line over here is perpendicular to that line over there. Okay. And remember, with analytical geometry, when you hear stuff like perpendicular or parallel, you start thinking about gradients. Because remember, perpendicular means that if this gradient, you probably just watched this in the previous video, but if this gradient is a half and the other line is perpendicular, it will be inverted and the opposite sign. So it'll be -2, the perpendicular line. Okay. The equation of BTD, this one, BTD, is given by 2y plus x equals 18. Okay, so they've given the equation of that line, and they've given the equation, it looks like this. I don't know if you can read that small, so I'll write it again. They've given it to us like that. And remember, we actually prefer it when y is the subject of the formula. So when we get to those questions, we may first want to rearrange and make that y the subject of the formula. Then they say AB is 15 units. So that's this line over here is 15. Okay, so the question says determine the gradient of AC. This is AC over here, and they want the gradient. Okay, now immediately, the only information they've given us is that this line, they've given us the formula, and they've told us that this one is perpendicular. We don't have point C, so we can't just use y minus y. But remember what I told you to think about. Think about the fact that these two lines are perpendicular. So if I can get the gradient of this one, all I need to do is invert it and change the sign to get the gradient of that line. Okay, so 2.1, let's first rearrange this formula. So 2y plus x equals 18. So we take the x over, we get 2y equals 18 minus x. Okay, then we get rid of the 2 by dividing everything by 2. So y is equal to 18 divided by 2 is 9, and minus x divided by 2 is minus a half x. I'm writing it like that so that you can see that this is the gradient. You may even want to write it like this rather, minus a half x plus 9, so that, if it's in this